So let's look at some trade-offs in random testing. And what I really mean here is advantages and disadvantages of random testing that might lead you to spend more or less time doing it. And so on this side, I'm going to put advantages. Over here, I'm going to put some disadvantages. So one of the main disadvantages of random testing, and of course this is something we spent a lot of time already dealing with, is that the input validity problem can be really hard. And a lot of people who give up on random testing, in my opinion, give up on it too early before they've gotten good results. And often it's this input validity problem that stops them. And so the fact is there might be some creativity required to get around this. For example, mutating existing inputs or gaining a good enough understanding of the structure of the input that we can actually generate valid random inputs from whole cloth. Oracles are hard too. So again, we need a substantial amount of creativity to deal with the lack of oracles. Something that people often like when doing testing is they like to have a fixed test suite, and they like to run it, and they like to know when it's done, that if they didn't get any failures, they can feel good. Random testing, on the other hand, has no stopping criterion. And so, for example, if you run a random tester on 8 cores for a day without finding any problems, that implies nothing about what you'll find in the future. You might find 6 or 7 problems in the next hour of testing. And in the process of doing this compiler testing that I've been doing for several years now, I found this to really be the case. I can start a compiler testing run on, for example, the latest version of GCC and LLVM, and I won't find anything for a long time, and I'll think to myself, gee, they've really sort of started to nail the issues. And then, just due to probabilities working out how they do, a bunch of problems will come out after a day or two. So another problem, and this is one we haven't really talked about yet, is that random testing may find unimportant bugs. And what I mean by this is that since random testing explores parts of the input domain that may not be often explored by real users of the system, it could be that the people developing the software under test are not remotely interested in fixing the bugs that are triggered by these strange inputs. And this can be frustrating, but it's really just very situational. Some kinds of bugs, such as buffer overflows in a web server or in a PDF reader or something like that, are almost mandatory to fix because they're so often exploitable. So those kind of bugs really can't be labeled unimportant by right-thinking developers. On the other hand, if we're talking about problems that really might not come up in practice, so let's say that with my C compiler testing, I generate a C function that's 100,000 lines long, and this fails to compile. Well, the compiler developers are almost certainly going to ignore me because people just don't write code like that. And similarly, if I make an identifier, that is to say a variable name, that's 800 characters long and that crashes the compiler, they may not care about that either. And so the general flavor of the solution to this problem is, first of all, to generate random inputs that are more like inputs of interest. So for example, when we're generating random C codes, we don't make really long functions. We don't make really long identifier names. We don't nest parentheses really deeply. And it could easily be that these things would find bugs, but we just don't really have any confidence that if we find these bugs, that anybody would care about fixing them. So we'd rather just not even find them.